Alright, today we're talking about representative particles. And what we're talking about here really, when we talk about the concept of the mole, we know that 1 mole is equal to 6.02 times 10 to the 23rd power. Again, that's like a dozen. If I say a dozen, you think 12. If I say a mole, you think 6.02 times 10 to the 23rd. It's just a really, really big number. And that's particles. Now, those particles can be a few different things. They can be atoms, molecules, or formula units. And we need to have a really good understanding of what each of those particles are so that we can make sure we're properly calculating the things that we're asked to calculate. So let's start with atoms. Atoms are the smallest particles that retain the properties of an element. So those are things that are found on the periodic table. So we're talking about atoms. We're talking about things that we find over here in our periodic table, right? Lithium and sodium and potassium and carbon and boron and phosphorus. All of those things, well, almost all of those things that are found on the periodic table. So if I am dealing with a particle that's found on the periodic table, then I'm just talking about an atom. Molecules and formula units, on the other hand, those are both compounds. They're going to contain more than one element. So molecules are covalent compounds. So we can think back to our previous units. We know the difference between ionic and covalent. Things like H2O, right? 2 nonmetals. Carbon dioxide, 2 nonmetals. So any compound that's composed entirely of nonmetals is a covalent compound, and we'll call that a molecule. Formula units, on the other hand, are the exact same concept. It's a compound, but they're composed of ionic compounds. So if we have something like NaCl, NaCl is an ionic compound. So anything that has a metal and a nonmetal is going to be an ionic compound. And that's review. That's stuff that we should know at this point. So that's how to distinguish those things. And the last thing we have here is diatomic elements. Diatomic elements are special elements that are so reactive that they are going to react with another atom of itself. And there are 2 ways to remember the 7 diatomic elements. One is Brinkelhoff. So that little acronym there, Brinkelhoff, tells you the 7 diatomic elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Or you can look at the periodic table, start with 7, and make a 7 that identifies 6 of them, and then hydrogen. So those are the 7 diatomic elements. And we would consider those to be molecules. Because oxygen, for example, is going to be O2, or chlorine is Cl2, or fluorine is F2. They will never exist by themselves as a single atom. Where if I was working with, say, lithium, lithium by itself is just going to be lithium atoms. So if I scroll down here and take a look at my examples here, NaCl, sodium is a metal, so that is a formula unit because it's an ionic compound. Again, we've done this before, just saying, is this ionic or covalent? H2O is a covalent compound, so it's a molecule. Potassium fluoride. Potassium is a metal. Fluoride is a nonmetal, so that is a formula unit because it's an ionic compound. Gold, Au, just one element, so that's an atom. Oxygen, just one element, but it's one of our 7 diatomic elements. So even though it has just one element, we're going to call that a molecule because oxygen's a diatomic. It will exist as O2, so it's a molecule. So again, pretty simple concept. something you just kind of have to recognize and memorize. But if you do not, it makes the mole concept very, very difficult, because we need to know what those particles are that we're referring to.